All right, it's now 1:04, so I'm going to begin as more people can file in. So hi, everybody, and welcome to today's webinar. My name is Eric Domenis. I am the Program Manager of Private Sector Innovation here at Canary. We are recording this presentation, and it will be available on YouTube shortly after the webinar concludes. The PowerPoint slides today were sent out ahead of time, so if you do have the slides on your screen, feel free to follow along. If you'd like to ask a question during the presentation, please use the Q&A panel that is available in the Zoom interface below. We do have a couple spots during the presentation where we will address any questions that are in the panel, so feel free to write questions at any time, and we'll get to them during those periods. Now I'd like to pass it over to my colleague, Annie, for French. Annie, you are on.
Yep. Bonjour à tous et bienvenue au webinaire d'aujourd'hui. Mon nom est Annie Jolicoeur, je suis coordonnatrice à l'exploitation des programmes chez Canary. Juste avant de débuter, simplement pour vous aviser qu'on enregistre la présentation et qu'elle va être disponible sur YouTube peu de temps après la conclusion du webinaire. La présentation PowerPoint devrait vous avoir été envoyée par courriel, donc sentez-vous à l'aise de suivre avec votre propre copie si vous le souhaitez. Si vous voulez poser des questions durant la présentation, s'il vous plaît, utilisez l'option Q&A dans votre menu Zoom. Il va y avoir des moments alloués durant la présentation pour répondre aux questions. Alors, sentez-vous à l'aise de poser des questions et d'inscrire vos questions dans le Q&A à tout moment. Sur ce, je repasse la parole à Eric.
Merci beaucoup, Annie. All right, let's advance my slides here. All right, perfect. So for today's webinar, we will quickly be going over some updates that are happening within the DAIR program, and then move right into what you want to see today, which is Secure Your Startup, which will be presented by Juan Diego Palomino, Ankur Dahia, and Sachin Agarwal. So quick updates right now with the DAIR program. We do have 2 new booster packs that are currently in development and are getting close to being published. And those are the Automated Data Pipeline for Data Analytics using AI by Intellius AI, and Cloud-Based Platform for Geospatial Intelligence with Machine Learning by Ecosystems Informatics, Inc. We do also have 2 brand new booster packs that were posted in the past month and a half. So please do check out the booster pack catalog for both of those. I would now like to pass it over to my colleague, Tom Vitez, who can give an update on DAIR migration. Tom?
Thanks, Eric. Hi, everyone. Just a quick update to let everyone know that are currently participating in the DAIR program, that we are almost complete the migrations of tenant accounts to an AWS subtenant model. We should be completing that by the end of next week. So if you haven't been migrated already, you will be very, very soon. And we encourage you to reach out to us if there's any problems with your instances once we've migrated them. Also, along the same timelines, rough timelines, there's a newer version of the Morpheus broker tool that you use to access and manage your hybrid cloud environment and instances in our DAIR hybrid cloud. There's going to be just some minor enhancements and changes, and we'll highlight those enhancements or changes at the time when we do upgrade production to the new version of Morpheus. So another thing to look forward to soon. Thanks, Eric. Back to you.
Thank you very much for that, Tom. I would now like to pass it off to our guests for today to go into securing your startup with Opta. So JD, Ankur, and Sachin, I will stop my share here and pass it over to you. Feel free to take over.
Hello?
We hear you, JD.
Hey. Hi, guys. All right. So I guess I'll go and start the little PowerPoint, not PowerPoint, Google Slide presentation now. Give me a second. Let me just start sharing the screen for this. All right. Okay. So, ladies and gentlemen, boys and girls, children of all ages, well, nice to go and see you here. And this is a little presentation of what Opta is and how we can go and help you secure your infrastructure and your organization in the cloud with Opta. Cool. So let's get started then. So a little bit about me. That handsome man over there is me. I'm the founding engineer at Runix. Previously, I worked at startups such as Flexport, Orbital Insight, and my specialties are on, I'm a DevOps engineer focusing on infrastructure on AWS with Kubernetes and GCP as well. So I've been doing that for the last couple of years. And this is how I got involved in all of this project. Cool. So let's get started then. What exactly is infrastructure as code? I always like to go and start by explaining the terms before jumping any further in, so that everyone knows what we're all talking about. So infrastructure as code is when you are trying to go and provision your cloud resources in a deterministic way based on either some code or templates, basically that it's written down, that people say, I want this time, I want this piece with this configuration, and so on and so forth. So that, so that then you have some sort of system that goes, reads it, understands, and executes on it. And it can be typically it's tracked as part of a repository. It's called infrastructure as code because it's supposed to live right next to your code. And I guess a nice way of compare and contrast is basically the opposite of this. I'm not sure how many of you have used AWS or maybe used GCP, but typically there's this online console, and that you can go and click in the UI. All right, I want to click here to provision an Ec2 instance or this EKS cluster. There's a couple of there's this hamburger menu that can pop up with all different configurations, and you need to click through it, and then you'll never be able to repeat that ever again. So it's the exact opposite of that. That's what we're trying to avoid here. Cool. All right. So this is actually what some infrastructure as code looks like. I just took a screenshot of some of the stuff I've been working here, and we can go and do this to analyze and make sure that we all understand what it is that we are dealing with. So what exactly is going on here? And this over here is based on AWS IAM service. This can be on GCP, it can be for Azure. This is just an example, but it works the same way for all of the different clouds. So don't worry about that. So first part is we're trying to go and create an IAM policy specification for role assumption trust. Here it is. So all right, so here's a new IAM policy document, and we say that we are going to allow the action of assume role from the EC2 service of AWS type service right there, and say, all right, that's who can assume this role, and we're calling this policy in our code node group. Then the next part is we create an IAM role with set trust. All right, so here we create the actual AWS IAM role, and this is the name that we give it, and we can pass in variables as part of infrastructure as code. And we say, all right, who can assume this role? We give this assume role policy right here. We drop it in as a JSON, and we add some special tags if we want. And lastly, now that we have this role, we can go and programmatically assign different policies to this role to give them permissions. Such over here where you're saying this has an Amazon EKS worker node policy, Amazon EKS CNI policy, Amazon EC2 container registry read-only policy. So we grant them all of these roles, and now this IAM role is fully all these permissions. Now the IAM role is fully complete with the desired permissions, with the desired role assumption trust. All of that written, templatized, auditable, and even can be code reviewed. More on that later. Okay, so now that I explained what infrastructure as code is, why do people want it? What's the big deal about this? Why is it better than what people usually do with the AWS console, the little hamburger thing, go to UI, click this, pops up the menu, and then select everything there. Why is this better? Well, there's a couple, actually, there's many good reasons. So first one, I think I already touched upon is repeatability. You have this written, somewhere in a template or code, and then you can do it again and again and again. And so it's going to be the same thing. That's one of the nice things about having something written down. It's also very resilient because now it's not, there's going to be no minor change that's going to go and make it off the rails. it's gonna if you keep it well, and it's going to always work for you. So more than that, and following up on that, there's also the communication as well. In that, suppose that there's this new person that's joining your team, and they want to know what is this, what's this resource, why is that, how is this database configured, and they don't need to go and read all about it by clicking the view and then all the different specifications. So, boom, right there. And not just for that, but for that database, but for any other resource that you want. It's all right there in writing. And that drastically helps people ramp up and understand what is this new environment that they're working with. All of this is, I guess, can be characterized as tribal knowledge versus explicit knowledge. I know that these are terms that are that are quite popular nowadays when with dealing with management and documentation, written written records, and this is exactly what's happening here. It's not like tribal knowledge where, oh, people just kind of know that this is how things were, this is how things are. No, this is explicit. Say this is how it is. Here's the documentation. This is how it should be. And it just goes down to the same thing. Why do we bother to write anything down? Why do we write laws down? Why do we write blueprints down? It's the exact same idea. And I know that Hammurabi approves. I'm a big history fan. All right, so cybersecurity. Let's start talking about that and what it means with infrastructure as code. So now that this is super important for cybersecurity, because now you know what is written down, you know what the source of truth is, you know what your environment should be like. You can go, you can audit it, you can analyze it, and now you can even go by putting it in a Git repository. You can have it code reviewed. You can code review the changes in your infrastructure. And that that would go and catch so many errors, so many possibilities for breakages or even vulnerabilities being exposed. All of this hardens all of every aspect of cybersecurity. It makes it so much better, but it doesn't go all the before it doesn't go all the way. I want to explain a couple of the infrastructure as code tools that there are nowadays. So there's the most popular of all is Terraform, and that's the sample I gave you. There's also Pulumi, which is based a lot on Python actually, and it's not as templatized as Terraform, but rather it looks and feels a lot more like Python code, and it's also really good as well. Highly recommend you guys look at all of this. AWS sort of pioneered this way back in the day with AWS CloudFormation. It's it's the same principles, although very specific to AWS, and a few it's not all of AWS resources, as only a few of them has like CloudFormation, and other documentations are not the best, but that's just my personal preference. Take a look at that as well. So it says pros, these are all declarative. They support low-level configuration. You can go as deep in as you want, and when you're specifying the cloud resources that you want to go and create. Many of these have great communities. Terraform, Pulumi, I think all of them have Slack channels. They are really these Terraform, Pulumi at least do, but they're really active. You can ask questions, and they're super helpful. So I really like that. We really like about working with them. Now, there are a couple of cons, and the first one comes to mind is that this is a steep learning curve. If you want to, you won't be able to go and write anything useful with these tools on day one. It's not happening. You need to understand how it works, what exactly is being created, and it's going to take a while to go and get up to speed. But then once you understand what's going on, you will understand how to deal with almost everything there. But then those first few weeks are going to be tough. And that is on top of the fact that you still need to be a DevOps expert, because these things they tell you they don't get rid of that requirement, and so you still need to focus on that. Moreover, there is no encoded wisdom here with the security, so you need to figure all of that. All of these cons, I'm going to go into a bit of detail, greater detail later on. And so, because all of this, I say that it gives you a false sense of security. And yeah, so same. So a little bit more on all of these cons now. All right, so what is missing from security? And the way I like to think about it is that with these, with Terraform, Pulumi, AWS CloudFormation, you now have something as fancy as this this airplane cockpit with all of these buttons, all of these levers, these gadgets, whizzes going around and saying, all right, you can control all of this to go and make this secure. So obviously now you can make it secure, right? You know how to manage all of this. You know what each of these things are going to do. Because I promise you, a good pilot on top of this, they'll know exactly what to do, but not for us mortals. And so that's the main problem. So just because it's something is written and reviewed doesn't mean that it's best practice. Humans are fallible, and your team will go and approve this change and saying, oh yeah, this looks good. And that is leaps and bounds greater than just a single person doing it, but still there is no guarantee that this thing doesn't have a bug somewhere. And this causes users, they need, as I mentioned earlier, they need to be, to use this in production, they need to be DevOps experts from day one. There's no way around that. And you can always go and use security scanning tools to go and make things better, but you still need to know how to go and set them up, and then also how to go and apply them and fix them. And so they'll tell you, it's like, oh, the altimeter is saying that this is that you are 10,000 feet above where you should be, and the air pressure isn't what expected. They need to know, okay, what does that mean? How do I fix that? So and these are so you still need all of that knowledge going in. And I keep saying from day one, because most people think that, oh, they can just go and fix this later on. But in reality, depending on what sort of setup you have, it may be difficult to correct later on. If you set up a database really badly, if you set it up in a VP, in a subnet that is publicly exposed, then you need to go and move it to a private one to make sure that it's secure. And there's no way around that except turning it off, creating a new one, and dumping all of the data there. You're going to need to go and move and restart your database to fix a mistake like that. So people think it's difficult to correct later. It's not difficult to correct later on. No, it is. It can be very difficult to correct later on. So you really need to go in and try to get it right ASAP. Okay, so I mentioned all of these things that that can go wrong with infrastructure as code. And what are we going to do about it? Well, this is exactly what we made Opta for. You can go and find it here. Here's our GitHub link. It'll appear later on. And what we're trying to do is we're trying to create a beginner-friendly infrastructure as code option, something that is secured by default, that all the basics are going to just work out of the box. But if users want, they can go and they'll have progressive configurability, so that you want these extra features and not there by default, you can enable them. You can keep working on that, but it always works it will always work for the average Joe just starting out in the beginning, and give them something secure. And of course, no lock-in. Because that's one of the things users are always worried about, is that, oh, they try to get this tool, they're going to be married for it for life. No, if you don't like it, you can always just walk away. Well, more on that later. And we even made it extensive. We also made it extensible with custom infrastructure as code. So we can if you have your own Terraform modules that you want to also include in your state, that we incorporate that. Our community is growing, and we are really friendly. And I guess the way that we like to think about it is DevOps on Rails. I hope that makes sense. But jumping in a little bit more on how it works. All right. So now I mentioned these principles, what we're trying to do, what exactly is happening under hood. And what's happening is that Opta is an intelligent wrapper around Terraform. We told you about how there's a lot of these gadgets, these inputs, fields that you need to go and put in, know what they need to do. Well, what we realize is that 9 times out of 10, people just want this golden path. People want the same thing over and over and over again. They want VPC, some public subnets, some private subnets, databases, clusters, workers go in the private, the load balancers go in the public. And knowing that knowledge, we baked it in to the Terraform modules that power Opta, and also I get wrappers around them that automatically go and link the modules together so that the expected inputs of one flow to the expected are gathered from the expected outputs of the others. And also handles a lot of we also handle a lot of corner cases with AWS that there's some failures that GCP as well that happen every now and then. Now all of this works through CLI commands. Opta is a CLI tool. You can go and download binary, and then you give it a series of YAMLs, one for your environment and one for each of your services in that environment, and it'll you execute it with that, and that's how it goes and builds your infrastructure as code and applies the changes that are needed. And to just give an example of how simple it is, let's take a look at this. This is one of these YAMLs. So I'll show you now. It is really that simple to go and get started. So what's going on here? You give it a name. This is for your environment, and say this is my staging environment. And you say what org are you in? So you have your org name. Cool. Now for provider, you mentioned this is for an AWS account. You give it a region. You give it the account ID. And they say, all right, what do I want to install in this environment? I'm trying to go and build this my staging environment for my web app for my company. And to start off with, well, what we want is space. So what does space do? It's always there. It just sets up the VPCs, the subnets I mentioned, a couple of KMS keys for encryption. That's very important for security later on. I'll get more into that. It sets up the K8s cluster. This is for Kubernetes deployments, and this again, this looks back on the base module. It finds out what are the public and what are the subnets, what are the private subnets, what's the KMS key, so that you can encrypt things for encrypt storage when written to disk, and it intelligently handles all of that and doesn't let the user worry about it unless you really want to again, as I said, it's progressive configurability, and so you can pass more inputs there. But by default, this will just work right off the bat. And on top of that, we want K8 space, which is a bunch of services on top of Kubernetes that are necessary to go and get started, such as the ingress, the service mesh, auto scaling, and so on and so forth. And this is all that it needs for a staging environment. And frankly, this would also work for production. You might want to add more things in the production environment, but this is it. This is this basic Kubernetes environment that can work for most web apps. Cool. All right. So features and Opta, as I mentioned, we're cloud agnostic. This over here, they mentioned these modules. They never mentioned AWS or GCP right there. All of these, if you were to set up for GCP, you will need to go and for this setup, you wouldn't need to change anything. It would just work just like this for GCP as well. Obviously, there's modules that are specific to GCP or AWS, like for an S3 bucket, stuff like that. But by and large, this basic setup, if people want it, it can be extremely cloud agnostic. Again, each of these environments are based for microservices. So this is a base environment. Then you would have a separate service YAML for each service or microservice that you want on top of it that would be able to reference this YAML and say, this YAML file and say, oh, I'm going to go and deploy it to this environment. Again, through this, it's easy to go and get dev environments as that demo was. And we even have some observability integrations that if you look at our different, in our documents, in our documentation, we have guides on how to go and get started with Datadog, with log DNA, and and a couple others out there. So really easy to go and set up because we're not doing anything weird. We're not doing anything off the golden path that again works for 9 out of 10 folks. And so all of that is pretty easy to go and get started with. Also build an auto scaling. One of those things for the K8 space, one of the things that we take care of is we make sure that that at least for Kubernetes, the clusters, the machines that are actually serving your web apps, they are auto scaling by default. People always say, oh my gosh, I need to go and configure this and you figure out how that works. Don't worry about it. It just works. And all of this can be, as touched upon earlier, can be extensible through Terraform, as Opta is a wrapper around Terraform. If you want, you can make references to your own Terraform modules, and Opta will just go and pick it up and assimilate it into this environment that it's building. And this is a security talk, and security is important for us. Security is critical for Opta. We wanted to be there from day one. So what we're trying to do is for all of our customers to make sure that at least with all of this infrastructure stuff, that they are SOC 2 compliant from day one. There's a lot of stuff that is still on the business level that needs to be done by humans. It's not something for infrastructure as code. It's something that humans need to talk about and need to figure it out. But at least this infrastructure part, making sure that everything that is persisted to disk is encrypted, that all of the EC2s that are running the web servers cannot be reached directly from public internet. All of that is taken care of from day one. That part is SOC 2 compliant. Cool. All right. So, and I want to explain a little bit more about this security that we have, because I mentioned a couple of points, but it goes actually a bit further. So as mentioned, more than just that, making sure everything encrypted to disk, we make sure that when you create environments with Opta, we have audit logs everywhere. Everything is audited. Everything's audited. There's going to be for AWS. There's going to be S3 and S3 logging bucket. Sometimes there's CloudWatch log groups. Everything is there, just ready for the others that they want. Storage encryption everywhere, as mentioned earlier. Private subnets for resources such as databases. DNS. When we do DNS, we do DNS subdomain delegation so that you can go and split your DNS easily through different to different environments based on prefixes. And thanks to the Linkerd service mesh that we install, you have MTLS from day one. And that means that once you have once you set up, go through the SSL setup steps, there will be all of your HTTP requests will be end-to-end encrypted, and that will be from day one. It goes to the load balancer encrypted, to the service encrypted, all the way to the pod, to the machine for it, and ends up as being served. All of that is encrypted. It never MTLS is never broken along in the TLS is never broken along the communication. So that's a guaranteed end-to-end encryption. And also whenever we have the RBAC roles, one of the dangers that we see is that sometimes services like to go and share the same IAM roles, and we don't do that. Everything has their own distinct IAM roles. There's no way that there's some accidental slip, and something that definitely should not have permissions gets too many permissions because of someone wrote it for another use case. We don't have that. Cool. All right. I've been talking a lot, so now I want to go to a little demo of what Opta looks like. So I'm going to go now to my to my command line. Where is it? Can everyone see can everyone see my terminal?
Yep, looks good.
Awesome. Cool. So first, I'm going to go and say, all right. So
actually, can you increase the font size a bit more?
Sure. Let me just clear here.
Thanks.
All good now?
Yep.
Cool. So there's going to be two YAMLs that we're going to be dealing with. So we're going to AWS live example.yaml. And let's see what we have here. This is So this over here is my extended sample environment. We have the base. We also have DNS. I did the DNS delegation configuration that you can read on our documentation, as there's some human needed steps to pass over the trust for your different DNS from whatever domain provider you have. They're no way really easy to do. We link it to CloudFront. So this actually comes with goes a little bit further beyond and actually has CloudFront as well. You have CloudFront's pointing to the K8s base from the K8s cluster. Here is a K8s cluster. And again, remember how I mentioned that there's the progressive configurability. Here I'm mentioning the K8s version, that I want to use spot instances, max nodes is 13, and enable metrics is true. So this is the environment that I'm developing with, that I'm going to be creating with, I created with Opta. Now that we're in demo, any questions so far, any pressing questions?
I don't see any questions currently in the QA panel, but if anyone does, please do put them in the QA panel and we will get to them.
Thank you.
This is Dawn. One thing I would like is if you could cover from examples. The Kubernetes was, Terraform was designed to be a cloud agnostic tool, but each plugin seems to have its own code framework that you have to follow, and it's slightly different per code. I heard you say that you have cloud agnostic style configuration that can be ported across both. But if you could sometime during the demo show how you handle a K8s cluster in, say, another cloud, where it wouldn't be called a K8s cluster or K8s version. Cool.
Right here, this is GCP. This I have a GCP example here, and we just call it K8s cluster. So this is one of the things behind that we manage behind the scene, because Terraform, it doesn't let you be this cloud agnostic. You need to say this is a GKE cluster.
Exactly.
And you say and then you, instead of K8s version, you need to say the channel. So what happens is behind the scenes we convert this to another type of module.
Neat. Gotcha. So you
work.
Yeah, that's what I wanted to make sure people were clear on, that there is an agnosticness to this, a cloud independence to this, that there isn't in any other tool I've seen. I just wanted some clarity on it, but also wanted it illustrated clearly. And that's fantastic, because that's really what us cloud agnostic people need, is a tool that will deploy where we want it, when we want it, with the same code base, no matter where we're at.
Yep. So said we try to be as cloud agnostic as possible. No, there's always a limit to that, right?
Yep. There's always going to be challenges, of course, but in general, as little as possible is good. Exactly.
Yeah. Good. We're on the same page. So I'm going to do Opta apply. So, and for this now, what's going to happen is actually I already have it verbose right now. So onset Opta debug, so that it's not super verbose. Opta. Actually, I'm going to do that so that you guys can know this to see explore. Those were some old credentials, those aren't going to work right now. And now Opta apply. There is a live example. Bear in mind, it's not going to be as verbose as this usually. This is all for debug. So I already, so spoiler here, I already applied this environment before the and created this environment before the this demonstration, because for those who don't know, creating a K8s cluster, creating the base, all of this in AWS, it takes time. It always takes time. There's no way around it. Same for GCP. I know that we don't want to sit around here for 15 minutes waiting for this to work. So I created this behind the scenes, and now it's chugging along. This last part is planning the changes. It's gonna plan, I think, next to no changes or something tiny, because it was already created and everything's good there.
So one of the cool things here, right, is that so you already applied it and you're applying it again. So it's idempotent. So you can do this like 100 times in any CI/CD platform and get that benefit of IaC and repeatable infrastructure, which is so secure, compared to point and clicking where you never get the same infrastructure the second time.
Yep. So here, all right, there are no changes. As I said, I already played this earlier, so no changes. So I'm just going to click yes. It's not going to do anything, but not to go and break the flow. It's acquiring the state log, and it's not going to do anything with it now. And boom. That's it. Here you can see the outputs that we have from this. If we want, we can even have better outputs, such as we do. Instead of that, we just do output. We can go and have these as JSON, except for the debug log statements that I mentioned earlier. And this explains, for example, what are your public NAT IPs addresses, so that these are going to be everything that requests of the internet will be shown as coming from your system. Here, the public subnet IDs, the private public subnet IDs. Here in the name servers for the hosted zone that we created for this, the Kubernetes cluster name, the endpoint, security ID, everything that might be valuable to go and know. Of course, the main front and center is that one. And stuff also like S3 log bucket, user that we created, VPC ID, it's all there. Cool. So now let's say I want to go and create. I have this nice environment, and I want to go and create a service. I'm working on a web app on HTTP service, and I want to go and deploy it here. How would I do that? It will be here with. We have an example with a new YAML called HTTP service.yaml. And this is it. So what is going on here? This small YAML. So firstly, it says, all right, what environments can I deploy this in? And you can specify many if you want to go from staging to production quickly. And then you need to go and specify the environment, the command line, or it'll prompt you afterwards to say, I want to go to AWS example. Maybe there was GCP example, you could go to that one, but it won't do that because there's only one environment right now. The name for it is HTTP bin. So I'm not sure if anyone here knows HTTP bin, but it's actually a really nice tool. It's really helpful if you want to go and start debugging your stuff, or having for your web environments, or if you want to go and have an example where things are working well, because you just go here, try it out. You can do stuff like, for example, this is what the get endpoint looks like. You can even check for your IP. Super useful in making sure that at least your infrastructure is all set up properly. So this is the example image that I'm going to be deploying. It's an HTTP service. It's listing on port 80. So here, as I mentioned, port 80. This is you can pass in environment variables. These are some HTTP bin specific environment variables, as I want to go and have extra logs there. And last but not least, how do I want to go and expose this? I want to go and expose it through this public URI. So HTTP bin.parent domain. And this is how it will be exposed. So again, this is as a K8 service in the Kubernetes cluster we create in this environment, and make sure that it can be exposed through this domain. Cool. Okay. So now we're going to Opta apply it.
So in the background, it's deploying this application on that Kubernetes cluster you created in the environment. And it's kind of setting up all that routing, the ingress, and all that good stuff without having to get into the weeds in the cloud, right? And it's doing it the right way.
Mm-hmm.
So, your TLS certificates are set up properly, your DNS is properly set up. I mean, that's great, right? So you don't have to do all that heavy lifting.
Oh, and so here's another neat part about Opta. When we're changes, we go and we show them like in this format. So we say, what are the cloud resources that we're creating based on what module, what's the action, create or delete. This is a low risk change as we're just creating things. And so here we're creating the K8 service. We have a hash string that's necessary for internal stuff. And here's the IAM role that we're going to be giving it. So vanilla role attachment key service, there was policy key service, so cool, create. So I hit yes to create.
Yeah, otherwise, how often do we just give owner or admin role to the service account and run everything? That's just wrong, right?
We don't do that here. And so now that we're deploying, when we deploy a Kubernetes service, we can even go and see the state of it, the state of the deployment, as Opta knows that what people want to know is what are the events that are happening, what are the logs, and it shows them right here just as asynchronously as the deployment is along the way. There's been a successful deployment, so there's that. So now I wonder what happens if we curl the domain. So what do we call it? Curl HTTPS. Actually, let's just go and figure it out. Opta output. And the parent domain was baloney.runx.x, but we are not going to baloney.runx.x. We mentioned it was going to be HTTP bin. So HTTP bin.baloney.runx.dev. What does that give us? Boom, there we are. And ta-da. And it works just like before. So you can see the IP address, the different headers that this is getting with. And yeah, you can hit this right now if you guys want. I'm going to be destroying it in an hour or so, but this is what this, and of course we have SSL by the right now, as I did go ahead and in the environment I did configure, I did do the SSL delegation. So now this is end-to-end encrypted entirely. And that's a little demo I have. I think that's going to be the that's a last part of the presentation. Oh wait, hang on, let me. Oops, sorry, didn't mean that. Part of the presentation. And yeah, so thank you so much for all of this, deep dives on request, and you can hear more about us here on our GitHub, our Slack, and our documentations. Okay, that's all.
Well, thank you very much, JD. That was an awesome presentation. Do we have any questions out there from just anybody watching? If you do, please do use the Q&A panel below in the Zoom interface. In the meantime, I'm going to quickly jump back over to talk a little bit about DAIR while we wait for some questions to come in.
Yeah, Eric, I have one question that's
by all
probably
means.
applicable to the community. How does Opta handle complex functions in a cloud-like organization, organizational impersonation? Those features have started to come to Terraform, but I'm wondering how you guys handle those kind of things.
I'm sorry, the question is a little bit vague. Could you go on? Could you elaborate on what sort of these complex functions? Maybe an example or some sort.
Yeah. An example would be impersonating a sub account in an organization to deploy a piece of code or a service inside a subtenant of an organization from the master tenant.
Is this for Azure?
No, this is for AWS.
Oh, tenants.
AWS organizations.
Oh, that's it. Oh, okay, gotcha. Sorry,
I can comment on this one. So currently in Opta, we don't sort of focus on accounts and identity, right? We depend on the user to handle that, and we'll just use whatever AWS credentials are provided to us. So doing something like this is definitely possible, but you would have to create like the right roles and then give the right permissions to Opta. Like going forward, we do want to like address that and build a layer that also helps solve these identity problems.
Gotcha. No, that's fair. It's like I've been using Terraform to do this for a multi-organizational model, right? And I'm very much aware of the limitations of a multi-cloud or organizational model system. I basically have to rewrite my code over again for each environment. So it's more of a wish list item for me than it is anything else. But no, it's an interesting tool, and I look forward to actually playing around with it and seeing how I can empower myself and the things I do every day.
Awesome. That's great to hear. And as always, like feel free to reach out to us on our Slack if you run into any issues.
Sure.
Guys, I have another question. Great presentation, JD. I like the power behind Opta here. You talked a little bit early in the presentation about the full audit trail audit capabilities. And I'm curious on two things. One is like how would you look at the audit logs, or are the audit logs only capturing what is done on the command line using Opta? Or I'll give you an example, or is it just everything? Because what if you have a multi-person development team or DevOps team that are maintaining, say, a staging and or a production environment? They stand up the infrastructure, get all the networking rock solid, all secure, and then somebody goes and uses the native interface to tweak a config or a network setting or open up another port. How could you quickly identify that change so that you can manage it back in the Opta environment?
That's a fantastic question. So there's two parts to that answer. So the first part is that the logs that we do, the auditing is not so much on the CLI command itself, but rather on the infrastructure that is created there. So for example, that Kubernetes cluster, it has audit logs for it has logging enabled for it, and also hang on, also for the VPC. So for example, even on VPC base.
We can't see your screen if you're sharing or wanting to share.
I'm so sorry. No, value log depends on. Sorry, there's a lot of logs here. Okay, so we create a log. We do create a log bucket, and for VPC. Okay, so it's CloudWatch. Yeah, so sometimes it's S3 bucket. Sometimes it's CloudWatch for different AWS services is what they want. But each of these, if they allow audit logs to be placed with CloudWatch logs or S3 buckets, we put them there. We always make, for example, here's the VPC flow logs, and we go and we put them in the to monitor traffic in the VPC. You will find the same thing for our databases, for our Kubernetes clusters. Anytime that they expose that said resources API allows for logs to be stored somewhere, we go and we put them there. Now, the second part is how can we track changes that happen like that and an extra port is exposed or the security group is expanded, is that infrastructure as code is intelligent. And this is just something that we inherited from Terraform, in that it'll scan all the resources that it is under its domain, under its control, and then it's going to compare and contrast it with the desired truth that is going to go and compare and contrast the true state to the desired one based on the configurability. So if someone in the team went and did something like that, the next time Opta apply is ran, it's going to go and catch it, and it's going to go and try to revert it back to the original form. Does that answer the question?
Yeah, I think so. That's perfect. So if you wanted to be super crisp on your environment, you could run what was the Opta command? The update or
Opta apply.
Apply. And you could, so Opta apply though actually does the work to reset to your known good secure config. What if you wanted to just run against the environment and just be verbose about what has changed, the delta between the coded config and what is different because somebody might have changed?
Great question. We have there's a flag -- detailed plan, and then it'll show you what changed in detail, and then you don't need to apply it. You can say no to the changes. You're like, no, I don't want to go and revert.
Okay, great. Thanks.
Mm-hmm.
Well, it looks like we have quite a bit of interest here in Canary to be possibly running Opta. That could be exciting. Any other questions from attendees here in the audience? Well, while we wait for some more questions to come in, I will finish up with the DAIR slideshow here. So before we finish up today's webinar, I would like to say that we are currently looking for a couple more booster pack builders. So a booster pack builder is someone who develops our booster packs. They are curated packages of both documentation, source code, and expertise from experienced Canadian businesses across the country here. These booster packs, becoming a builder makes you eligible for a one-time payment of up to $50,000 Canadian, along with the connections to the DAIR community and beyond, and exposure and recognition for your work. If you are at all interested in becoming a booster pack builder, we do have a list of emerging technologies that we are targeting. Please do check them out on our website, www.canary.ca/cloud. You'll be able to find the booster pack builder page and our current booster pack catalog page there as well. So if you are interested, please do check it out and submit an expression of interest, otherwise known as an EOI. So if there are any other questions today, let's take a look. I'm not seeing any others in the QA panel. Last call for questions here in both the chat and the QA panel. If you are writing a question, you can also just raise your hand real quick and we'll let you finish writing in that question. I am not seeing any others come in, so I would like to thank I would like to thank all of our speakers today. So JD, Ankur, and Sachin for their great presentation. Thank you again for our attendees who came and watched our webinar, and hopefully you are as excited about Opta as we are. So thank you very much for your participation today, and we hope to see you for the next webinar. Oh, before we end, I did see Don fire his hand up. Don, do you still have a question for the Opta team here?
No.
Okay.
No, it's cool. Just hit a button by mistake. My fault.
Oh, all good, all good. Sachin, I saw you on mute as well. Is there anything you'd like to say?
Yeah, I just wanted to bring this up that so Opta, we saw it deploying the environment and then, starting up an application on Kubernetes. But there is a whole big catalog of modules that is, these Terraform curated modules, which Opta has hardened, and then now you can stand up databases and use all sorts of other popular cloud products out there, even outside the providers like MongoDB, Atlas, or what have you. So it's a much bigger ecosystem than just setting up your environment or deploying your application. You can actually deploy your whole stack using Opta and be sure you're secure on day one.
Yeah, thank you for covering that, Sachin. I just wanted to go through a little hello world example, but yeah, very extendable. We cover Postgres, MySQL, Redis databases, S3 buckets, CloudFormation, MongoDB, Lambdas, and yeah, we are going silly with all of those.
Perfect. Thank you for that, Sachin and JD. I believe this will bring us to the end of the webinar today. So thank you again to everybody for your participation, and we'll see you at the next one. Have a great day.
Thanks.
Thanks, everyone.
Thanks. Bye.